In Lesson 3-4, examples 1 through 3, you will be writing and graphing direct variation equations. Direct variation equations are described by an equation of the form y equals kx, where k cannot equal 0. The equation y equals kx illustrates a constant rate of change, and k is the constant of variation, also called the constant of proportionality. You'll want to make sure you have in your notes the form y equals kx. All of the equations today are going to look like this, where k is the constant of variation, also known as the constant of proportionality. In example 1, it says name the constant of variation for each equation, then find the slope of the line that passes through each pair of points. So in this first example, the equation is y equals negative 4x. So the constant of variation, I'm just going to call that CV. The constant of variation in this equation is equal to negative 4. Because remember, k is our constant of variation. It's the number in front of x, the coefficient of x. So negative 4 is the constant of variation. Now for the slope, you can either use the slope formula or you can just do rise over run. And in this case, we're not rising, we're falling 1, 2, 3, 4. So we're falling 4 and we are running 1. So the slope, or m, is equal to negative 4 over 1. And negative 4 over 1 is really just negative 4. In our next example, if this is our equation of the line, y equals 1/2 x, the constant of variation is going to equal 1/2 because that right there is k, or the coefficient of x. Now for the slope, slope is equal to, remember, rise over run. So to go from this point to this point, we rise 1, 2, 3, and we run 1, 2, 3, 4, 5, 6. 3 over 6 is 1/2. Notice that the constant of variation is the same thing as the slope in both of these examples. That is always going to be the case in a direct variation equation. This number right here, the constant of variation, is the same thing as the slope of the line. Example 2 has you graphing direct variations. Direct variations always go through 0, 0. So the first thing I would do is to graph or plot 0, 0. And then from that point, you're going to use the slope, or the constant of variation, to find another point. In this case, k, or the slope, is negative 6. We can write negative 6 as negative 6 over 1, which means we're going to rise, or in this case, fall 6 and run 1. So after we graph 0, 0, we're going to go from that point, we're going to fall 6 units, 1, 2, 3, 4, 5, 6, and then we're going to run to the right 1. You only go in a negative direction one time when you're graphing a line that has a negative slope. Then you would connect those 2 points with a straight line. You may want to try these next ones on your own. The first thing I would do is graph 0, 0, because all of these are going to go through 0, 0. And then we're going to go ahead and write the slope as a ratio. We're going to write it as a fraction by making it 6 over 1, which means we're going to rise 6 and run 1. So from 0, 0, we're going to rise 6, 1, 2, 3, 4, 5, 6, and we're going to run 1. Since it's positive, we went in a positive direction for both of our movements. And then we're going to connect that with a straight line. and you'd put arrows on the ends to show it goes on in both directions. Now for our next one, we would plot 0, 0. And then since the slope or constant of variation is 2/3, that means we're going to rise 2 and run 3. Since it's positive, we're going to go up 2 and we're going to run 3. Then we're going to go ahead and connect those 2 points. Sometimes I like to make a third point just so it makes connecting them easier and more accurate. So I'm going to go from the point I just made and rise 2 and then run 3 more. Now let's go ahead and connect that with a line, put arrows on both ends to show that it keeps going. Next one, y equals negative 5x. Negative 5 can be written as a ratio of negative 5 over 1. So we're going to plot 0, 0. And then this time, since it's a negative 5 over 1, we're going to, instead of rising 5, we're going to fall 5. 1, 2, 3, 4, 5. But then we're going to run to the right 1. Remember, for a negative slope, you only go in a negative direction once. And if I wanted to, I could go down 5 more and to the right 1 again, just to make my line more accurate when I go to draw it. And arrows on both ends. All right, last one, plot 0, 0, because all of these are going to go through 0, 0. And then this time it's a negative 3/4. Since it's a negative slope, you're going to go in a negative direction just one time. I always do it right away. So I'm going to go down 3 and then to the right 4. Down 3 and to the right 4. Now, if you wanted to, you could have gone up 3, but if you went up 3, then you would have to go left 4 because you need to go in a negative direction one time. And then connect those with a line, arrows on the ends. One thing I like to do when I'm all done as well is look and see if it makes sense. If it's a positive slope, it should be going upwards. If it's a negative slope, it should be going downwards. And the bigger the slope, the steeper the line. This is what I was just got done talking about. If it's a positive slope, it's going to be going upwards. If it's a negative slope, it's going to be going down. The next thing we're going to do is we're going to write and solve direct variation equations. So suppose y varies directly as x and y equals 72 when x equals 8. Write a direct variation equation that relates x and y. Well, remember, y equals kx is the form of a direct variation equation. So what we're going to do is we're going to plug in the stuff that we know and figure out what k is. So if it says it varies directly, it's going to be in this form, y equals kx. So in place of y, we're going to put a 72. And in place of x, we're going to put an 8. So this is 72 equals k times 8. To solve this for k, we would divide both sides by 8. So that gets us k equaling 72 divided by 8 is 9. Once I know that k equals 9, now I'm going to go and I'm going to write that right there. But now I'm going to leave my variables as x and y. So y equals, and we found k to be 9, and then x. So our direct variation equation that relates x and y is y equals 9x. Basically, we figured out what k was, and then we put that right there in place of k and left x and y as our variables. So there's the equation. Now for part B, you use that direct variation equation to find x when y equals 63. So basically, we're going to go here, we're going to plug 63 in for y. So if this was our equation, y equals 9x. If we want to find x when y equals 63, we're going to plug in 63 for y and solve it for x. To solve this for x, you would divide both sides by 9. X is going to equal 7 because 63 divided by 9 is 7. You may want to pause the video and try the next one on your own. Suppose y varies directly as x and y equals 98 when x equals 14. Write a direct variation equation that relates x and y, then find y when x equals -4. Sounds really fancy and smart, but really what we just need to do is write down y equals kx because we said it varies directly. So it's a direct variation. Now we're going to plug in this and this for x and y to figure out what k is. So 98 equals k times 14. Now you're going to divide both sides by 14. 98 divided by 14 is 7. So k is going to equal 7. Once we know that k equals 7, we're going to go and just put that right there to get our equation. So y equals 7x. Now to find y when x equals -4, when x equals -4, we're going to put that right there. Y equals 7 times -4. 7 times -4 is -28. So y equals -28 when x equals -4.